For this question, we have a couple parts which we'll do in segments, but the overall question is we want to evaluate these limits given, but using algebraic techniques, okay? Now, we will need to show our work for these, so as we go through, we'll want to recall all the algebra techniques that we've used up to this point, such as factoring and canceling, multiplying by the conjugate, working with kind of getting common denominators or canceling fractions out. All of those techniques we've done in class and done examples of, we will want to utilize here, okay? So let's tackle our first question, part A here. A is asking us to take the limit as x goes to 5 of this rational function here, x squared minus 25 over x squared minus 4x minus 5. Now, as usual with limits, what we like to do is we like to do direct substitution. So we like to plug in x is 5, and we want to see if the outcome of this limit will be a value or if we get some indeterminate form, right? Because if we just get a number, that means we can stop there. We don't need to do any of the extra techniques. So here, if I plug in 5 in the numerator, we get 25 minus 25, which certainly is 0. And in the bottom, if you plug in 5, you get 25 minus 20 minus 5. So 25 minus 25, that would also be 0. Okay, so we are getting some indeterminate form, which means that I do need to use one of my algebraic techniques to try and simplify this. And it should be hopefully clear to see that for rational functions, a good technique would be to factor and cancel, right? And so in the numerator, I'll get this to factor to x plus 5, x minus 5, okay? Difference of squares. And in the denominator, we need two numbers that multiply to give me negative 5 and come together, adding or subtracting to be negative 4. It appears as though I need a 1 and a 5 to multiply to 5. The negative 5 and positive 1 would work because I have to get negative 4, right? So negative 5 plus 1 would be negative 4. Now, what do I notice? Well, here, x minus 5 cancel out. That's exactly what we'd hope for because these are the terms that are causing my numerator and denominator to go to 0 when x is equal to 5, right? We should have this intuition that this is already a factor in the problem. So when these cancel out, what we're left with is this limit as x approaches 5 of just x plus 5 divided by x plus 1. We now do direct substitution. When you plug in the 5, we would get 5 plus 5, which is 10. And we would get 5 plus 1 in the denominator, which would be 6. Therefore, my final answer would come out to be 5 over 3. That would be the limit from up here. Okay? So again, our process was we plugged in early direct substitution to see if we had an indeterminate form or not. We did end up getting indeterminate form 0 over 0. And so we did our factor and cancel technique where we assumed x minus 5 would be a factor based on what we know about the limit approaching 5. We canceled those terms out. We got a nice limit here that's a little bit easier, and we can actually plug in at 5, and we got our final answer of 5 over 3. Okay, so that's our question 2, part A.